Today we're going to focus on the double angle and half angle identities, and we're going to do several examples related to these formulas. So we'll refer back to this list, which is on your official formula sheet for Chapter 9. In this first example, it provides you with cosine and sine ratios, and they tell you to look at the fourth quadrant. If you notice, what they're asking for in part A is sine of theta over 2, which is some angle divided by 2. So that's a half angle. And so part A, B, and C are all referring to half angles. So now the question is, which formula are we going to use for part A, part B, and part C? For sine and cosine, it's easy because there's only one formula for each of these. So we know we're going to use this formula and this formula for part A and B. But for part C, how do we know which one to use? Well, figure out which one seems the easiest and also what information are you given. Of the three tangent formulas, the first one would be great if you were only provided cosine. You could use that. But since we're given both sine and cosine, I would use one of the bottom two tangent formulas. So just to make it easier, we're just going to use the middle one. So for part A, we're going to do plus or minus the square root of 1 minus cosine theta over 2, and we're going to substitute in the information that we were provided with. So it's 1 minus 12 over 13 over 2, and 1 could be rewritten as 13 over 13 minus 12 over 13 over 2. So that would give us 1/13 over 2, which is 1 over 26. And since we want to rationalize the denominator, let's rewrite this as root 26 over 26. Now the question is, do we want to use plus or minus? So if you look at this note, it says for half angle formulas, the plus or minus is determined by what quadrant theta over 2 is in. So if you look at quadrant 4, if we were to draw this triangle out, so they gave us cosine. Cosine is adjacent over hypotenuse. We could draw a triangle that has a 13 as a hypotenuse and 12 as an adjacent side, which we would know the y-coordinate would be -5. And you could verify that sine really is opposite over hypotenuse, which is -5 over 13. So that's where it is in quadrant 4. But if we were to look at the half angle, right, if we took theta and divided it by 2, what happens if we take the rest of the inequality and divide it by 2? So 2 pi divided by 2 is pi. 3 pi over 2 divided by 2 is 3 pi over 4. So let's figure out where pi is and where 3 pi over 4 is. And we know that theta over 2 has to end up in quadrant 2. So what do we know about ordered pairs in quadrant 2? We know that the x-coordinate would be negative and the y-coordinate would be positive. And so if we're looking for sine, that would correspond with the y-coordinate, which we would know would have to be positive. So our final answer for this problem would be positive root 26 over 26. And you don't need to list the positive sign. We know that it would be positive even if we left off that plus sign. All right, so we're going to do something very similar with part B. So that's cosine of theta over 2. And we've already determined that quadrant 2, cosine would be negative. So whatever we get for our answer, we need to look for the negative version of that. So we're going to use the formula. So it's plus or minus square root of 1 plus cosine theta over 2. And we're just going to substitute in the given information. So we have 1 plus 12 over 13 over 2. And just like before, let's look at 1 as 13 over 13. So 13 over 13 plus 12 over 13 over 2. That would give us 25 over 26. And we need to simplify and rationalize. So that would give me 5 root 26 over 26. And it would either be positive or negative. But because we were looking at the negative version, we would have our final answer be -5 root 26 over 26. And for the last one, remember we said we were going to go with the middle formula. So we're going to do 1 minus cosine of theta over sine of theta. And we're just going to substitute in the given information. So we were given 1 minus 12 over 13 over negative 5 over 13. All right, so we know that 1 is 13 over 13. So 13 over 13 minus 12 over 13 is 1 over 13 over negative 5 over 13. And then we can cancel out those 13s, and we're left with negative 1/5. If you want, you can verify that we would have received the same answer had we used any of the other formulas. So if you substitute in the given information, we would get negative 5 over 13 over 25 over 13, and you would cancel out the 13s, and you'd get negative 5 over 25, which is, in fact, negative 1/5. And then for this other one with the square root, we would have 1 minus 12/13 over 1 plus 12/13 plus or minus the square root of 1/13 over 25/13, which is plus or minus the square root of 1/25. And if you take the square root at the top, you get plus or minus 1, and the square root at the bottom, you get 5. Now, you would have to pay attention to what quadrant it's in, and so tangent would be sine over cosine, which would be positive over negative, and that would tell us that our answer would be negative 1/5. In number 2, now we have a double angle. So we're going to look at the formula for sine of 2 theta, which is 2 times sine of theta times cosine of theta. And so we have some of the information, but the rest of it we're going to have to figure out on our own. So we know sine is negative 1 over 10, but now we have to figure out what is cosine. And so if we look back at our identities, we could say that sine squared plus cosine squared is equal to 1. So I could do negative 1/10 squared plus cosine squared is equal to 1. So that's 1 over 100 plus cosine squared. And I'm going to change 1 to be 100 over 100. So cosine squared is equal to 99 over 100, which means that if we take the square root of this, we would get cosine to be either positive or negative 3 root 11 over 10. All right, now let's look at what quadrant they're referring to. So 270 to 360 degrees is quadrant 4. And so in quadrant 4, we know that ordered pairs are positive and then negative. So this would mean that cosine would be positive 3 root 11 over 10. And so we're going to substitute that back into our formula. And so we have 3 root 11 over 10, and now we just need to multiply. So on top we would have 2 times 3, which is 6, and we'll put the negative sign there. So negative 6 root 11 over 100, and we probably should reduce that to negative 3 root 11 over 50. In number 2, we're going to look at the cosine double angle formula. Now again, we have 3 to choose from. So choose the one that would be the easiest. We have sine given to us, so we could just go with this bottom one right away, because what if we had made a mistake when we calculated cosine? Or now that you do know cosine, you could use either of these two formulas. So let's use the 1 minus 2 sine squared formula. So we have sine to be negative 1/10, and we need to square that, so that would give us 1 over 100. We need to multiply that by 2, so that would give us 2 over 100 or 1 over 50, and so 50 over 50 minus 1 over 50 would be 49 over 50. And you can verify that if you had used either of the two other identities, you would get exactly the same answer. For all these problems, we should start off by figuring out what quadrant we're in. So this is quadrant 1. And if you want to draw out a picture, that will probably help you for this problem. So if we divide both sides by 5, we're going to get sine of theta to equal x over 5. And we know that sine is opposite over hypotenuse. So I would draw a triangle in the first quadrant that has an opposite side of x and a hypotenuse equal to 5. So we can figure out the missing side if we use Pythagorean theorem. So we've got x squared plus b squared equals 5 squared. So b squared is equal to 25 minus x squared. And then b is either plus or minus square root of 25 minus x squared. So now we know that since we're in the first quadrant, this would be positive square root of 25 minus x squared. And then we can do the problem from here. So now we're going to use the double angle formula for sine, which is 2 times sine theta cosine theta. And so for sine, we want to look at opposite over hypotenuse, which we were given, x over 5. And for cosine, we're going to look at adjacent over hypotenuse. And then we just need to multiply all the numerators. So we get 2x times the square root of 25 minus x squared. And then all the denominators is 5 times 5, which is 25. And then nothing simplifies here, so that would be our final answer. For cosine of 2 theta, we're going to use, I think the easiest one would be 1 minus 2 sine squared theta, since we were provided with sine. We know sine is x over 5, and we just need to square that. So square first before you multiply, and you get x squared over 25. And then I'm going to multiply, and we get 2x over 25. So I'm going to change this 1 to be 25 over 25. So now I have common denominators. And now we get 25 minus 2x squared over 25. In problem 4, we're given two sides of the triangle. And if you remember your Pythagorean triples, you can figure out that the adjacent side is equal to 24. And I'm just going to label which ones are the opposite and hypotenuse. And if you don't remember 24, then you can use Pythagorean theorem. So for sine of 2t, we're going to do 2 sine t cosine t. And we just need to look at what is the opposite over hypotenuse. So that's 7 over 25. And the adjacent over hypotenuse, which is 24 over 25. So when you multiply across, you get 336 over 625. For cosine of 2t, pick any of the equations for cosine of double angles, and I'm going to go with 2 cosine squared t minus 1. So I need to figure out what's cosine, which we figured out in part A was 24 over 25, and I need to square that. So when I square that, I get 576 over 625, which I need to multiply by 2. And then I'm going to change 1 to be 625 over 625. And then when I simplify, I get 527 over 625. For tangent of 2t, we're going to look at the double angle formula for tangent. So we've got 2 tangent t over 1 minus tangent squared t. So we know tangent is the TOA in SOHCAHTOA, and that's going to be 7 over 24. So we have 2 times 7 over 24 over 1 minus 7 over 24 squared. And that's going to give us 14 over 24 all over 527 over 576, which is going to give us 336 over 527. The other way to do this problem is to remember that tangent is sine over cosine. So we could do sine of 2t over cosine of 2t. And we've already calculated what are sine of 2t and cosine of 2t. So we could use our answers from part A and B to figure out part C. So I've just put in what we got for sine of 2t and cosine of 2t, and then you'll see that the 625s cancel. So you get 336 over 527, just like we got using the identity sheet formula. For problem number 5, what you need to do is think about, is this a good half angle or a double angle? Either some angle on the unit circle divided by 2 or some angle on the unit circle multiplied by 2. So if you divide it by 2, you would get 82.5, which does not really give you anything special. But if you multiply it by 2, you get 330. So that's the angle that we want. So we're going to rewrite sine of 165 as sine of 330 degrees divided by 2. So now we can look at our half angle formulas. So if we go back to our half angle formulas, we have plus or minus the square root of 1 minus cosine of 330 over 2. Cosine of 330, we would look at the x coordinate, and that would be root 3 over 2. So I'm going to change 1 to be 2 over 2, and then we're dividing it all by 2. So if we subtract on the numerator, we get plus or minus the square root of 2 minus square root of 3 over 2, and then over 2 again, so really over 4. So now we could take the square root of the top, so we've got plus or minus square root of 2 minus square root of 3, and then the square root of 4 we know is 2. So now we have to think about, is this going to be positive or negative? So let's think, where is 165 degrees? That's in quadrant 2. And in quadrant 2, we know that it's negative and then positive. And since this is sine, we'd be looking at the y coordinate. So this would be positive. All right, for the second one, for part B, we have cosine of 165, which we know we're going to think of as cosine of 330 divided by 2. And so we're going to use the half angle formula again, which is plus or minus, this time 1 plus cosine of 330 divided by 2. So very similar to this last problem, we're going to do plus or minus over 2 plus root 3 over 2 over 2 and square root of all that. So we're going to add the numerator together. So we get 2 plus square root of 3 divided by 2, but then divided by 2 again is really divided by 4. And that gives us either plus or minus 2 plus square root of 3 all over 2. The numerator is still under the square root. So this time, since we're looking at the cosine, we would look at the x coordinate. So this we know would be negative. Finally, for tangent of 165 degrees, we're going to look at our half angle identities for tangent. So I would select whichever one looks the easiest. And again, this middle one probably looks the easiest. We don't want to deal with a radical, and we don't want to deal with two terms in the denominator. So we're going to go with this one. So it was 1 minus cosine of the angle, which is 330 degrees, because remember 330 divided by 2 gives you 165, over sine of 330 degrees. So we know that cosine of 330 was root 3 over 2, and sine of 330 we can figure out is negative 1/2. And now we just need to simplify. So we're going to change 1 to be 2 over 2 again. And we have 2 minus square root of 3 over 2 all over negative 1 over 2. So we're going to cancel out our 2's. And then we have a negative sign on the bottom, so it's really negative 2 plus square root of 3. All right, so number 5 would be an easy one to check in our calculators, but we're going to first make sure that we're in degree mode. So for each of these problems, we're going to do sine of 165, and then we're going to type in what we had as our answer. So we had the square root of 2 minus the square root of 3, all divided by 2. So I'm going to hit enter first and then divide by 2. And that should give me the same thing. So I know that part A is good. Then we're going to do cosine of 165 degrees. So now we're going to type in what we got as our answer, which was negative square root of 2 plus square root of 3. And I'm going to hit enter and then divide by 2, and I should get that decimal, which is good. And then the last one, we're going to figure out what is tangent of 165 degrees. So I'm going to see is negative 2 plus square root of 3, equivalent to what we just got as a decimal. And it is, so we know that all of our answers are correct. So for numbers 6 and 7, we're going to prove the identities using either the sum and difference identities or the double angle identities. So if we could expand sine of 2 theta to be sine of theta plus theta, let's just prove that the double angle formula really is equivalent to 2 times sine theta times cosine theta. So if we look back to our sum and difference identities, when we do sine of some angle plus another angle, it's sine of the angle times cosine of the second angle plus sine of the second angle times cosine of the first angle. And we have sine cosine plus sine cosine of just theta. And so that really is 2 sine theta, cosine theta. So that does match up with what we wanted on the right side. For B, let's expand sine of 2 theta again. We just did it in part A, so we know that that could be sine of theta, cosine theta, plus sine theta, cosine theta, all over 2 sine of theta. And so in the numerator, I would factor out a GCF, and if I do that, I get sine times cosine theta plus cosine theta over 2 sine theta. And I'm going to cancel out my sines. That's my common factor. In the numerator, I get cosine theta plus cosine theta. That's 2 cosine theta all over 2. And then I can cancel out my 2's. And that gives me just cosine, which is what we wanted on the other side. Number 7, it says to use the double angle identity on the left side. So let's expand our cosine of 4 theta into 2 times 2 theta. And so what's our double angle for cosine? It can be 1 minus 2 sine squared of whatever angle it is that we're doubling, and that would be 2 theta. Okay, so now let's figure out what is sine of 2 theta. So now let's expand sine of 2 theta and then square that. So we have 1 minus 2 times, and the double angle identity for sine of 2 theta would be 2 times sine theta times cosine theta, but we need to square that. So now we need to square everything in there. So 2 squared would be 4 times sine squared times cosine squared. And then we need to distribute our 2, so that would be 8 times sine squared times cosine squared. And that is exactly what we wanted on the right side. And then we're all done. All right, if you have any questions, please ask your teacher.